So if you look at this space, it seems simple enough, but if I unhide everything, you can see that there's this just...
Jesus,
and,
oh my God.
This is
Holy shit. I swear there's a game behind all that. So Double Fine released a video a couple of days ago where they showcased some like behind the scenes kind of stuff for how they use Unreal Engine to develop their game Keeper. I've always looked up to Double Fine because I think they're really, really good at using the tools that they have to sort of express themselves and drive an artistic vision or a narrative vision or whatever through like the tools and the means that they have. I think they're really, really good at that. So I think this video is going to be really, really interesting to look at. But also, I just sort of want to give my impression on things and see if there's anything that I can learn and sort of bring you guys along and see if I can provide any meaningful commentary to it. So I think it's very interesting when other developers share these kind of things so we can all sort of like collectively learn stuff of like how things were done, because there are so many ways to do the same thing and sort of there's so many ways to row the ship to port. If you don't know me, my name is Snoot. I'm a solo freelance game developer from Sweden. I've been working with game dev for over a decade, and I'm probably best known for working on a game called Satisfactory, where I both worked as a programmer and a community manager. All right, anyways, let's check it out.
Hey everyone, my name's Lee Petty,
What's up,
and I'm
Lee?
the director of Keeper. Today we're going to show you some behind the scenes footage here of some of the techniques and the way we built the world of Keeper inside Unreal Engine. What we're looking at right now is the game running right here in the editor. You can see that I'm playing, but if I escape out of this.
All right, so I already want to mention something that I noticed immediately from the get-go. And one thing that I'm always interested about is like whenever you use Unreal Engine, you can customize Unreal Engine and you can extend it. You don't even need to like compile from source to be able to do that. You can just add like things on top of the UI that already exist. So one thing that I noticed immediately is that they haven't really done that up here. Like usually you can have like buttons that do specific things for like environmental artists or like if you want to have short commands or whatever. But one thing that I do notice is that they have these like extra menus up here. So they have this Double Fine menu, which doesn't really say much. Pagan Idol, I have no idea what that is. And Double Fine Zone, which is like, what's the difference between these two bad boys? I'm assuming that like when you do make extensions for the editor, if you have multiple teams working on different projects, if one team is like, hey, we figured out this really cool like environmental mesh shaping tool that's really useful, then you'd want to share that with like everyone at the studio, not just for that specific team. So sometimes you can create like these plugins that you can just have most people use. And I'm assuming when they have these like menus here that that's sort of what they've done. They've made like tools that maybe everyone at Double Fine can take advantage of. So all their projects have these sort of add-ons. I don't know. I'm just like sort of guessing. Maybe they'll talk more about this later.
And what we're looking at is actually what the developers look like while putting this game together.
Yeah, this is a mess. This is, every time you do anything, you have to look at this shit. You can turn these gizmos off, by the way, if you don't want to look at this. But yeah, it's showcasing a lot of different things. Here you have like splines where I'm guessing they have these like flock behavior that moves through the splines here. And you can have like lights that have gizmos to showcase. And you can like sort of customize what you want to view when you're in this viewport. Here are different like bounding boxes for volumes that probably do different things. Arrows that just indicate like which things are pointed. So like if you have like an explosion outwardly, you have like an arrow to show this. So there's a bunch of stuff here. And I can also tell from this view, I can tell that they're using the partitioning system. So like their Unreal's world managing system where like it loads and unloads actors into the scene. I can see the data layers here. And these are like layers on top of the partitioning system that you can sort of decide like when to load in and out.
We have a lot of different types of objects that are organized here, some of which are turned off. So you can see that, for example, I've turned off collision, but if we turn on collision, you can see some of our collision objects. A lot of these splines are cameras and other paths. So,
oh, interesting. Are they using splines to like set the camera position, and when the player moves, the camera like moves along that spline? Because like usually you put the camera like on the player character, like it's part of the same thing, like the camera is part of the player basically, and then you get a fixed camera. If you want to do any specific movement, then you just program the camera on the character to do something. But doing camera movement on spline makes sense for this kind of game where like you're probably moving between different cameras.
What I want to show you though that's really interesting, I always find this super interesting when I see footage of other people's games is, you know what it looks like when you're playing it, but what does it look like when you start panning around and you're sort of seeing, we didn't really need to build what was out of here. Now, you might ask, well, why is there even anything out there? And sometimes these are helper objects. Sometimes these are things that we want to cast shadows, which is the case here. So some of these simple collections of objects are casting shadows.
I just want to touch on the thing he said where it's interesting to see how other people do it, because it is very interesting. It's very interesting because there's so many different ways to do the same thing. It's so many ways to like achieve the same effect in so many ways. You can make really clever like materials to do something, or you can just block out the scene in a specific way to create the same effect. And they have different advantages and disadvantages. So I agree. It's very interesting whenever developers showcase stuff like this, because then you get to see like how it actually works behind the scene.
You could even look at the wireframe. We are using nanite, which is a feature of the Unreal Engine that allows you to use very dense mesh. And that was important to us because we sort of hand sculpted a lot of our environment, and we really wanted that feeling. You can see we can get nice and close here. You can even see we even have these sort of like brush and rake marks on the object.
So one thing I'll touch upon on nanite specifically is like a lot of people tend to view nanite as like this magical, like, oh, you can do so much things and have so much more detail with it. There are some disadvantages with nanite, and the specific disadvantage that I've experienced when using it is that you don't get like a perfect representation of your mesh because it needs to convert the mesh into that new geometry space to be able to virtualize it, which also requires a lot of memory. And even when you do that, you still need to have the core mesh loaded to do lookups on it. I'm not entirely sure how virtualized geometry shaders work. Memory is a disadvantage, obviously, but one of the things that I've often encountered is that like if you have something that isn't super geometry dense and it has really sharp corners or very specific shapes, then nanite might not always give the best representation of it. And you can tweak some of these variables, but it's not always perfect for everything. But for like stuff like this, when it's like rock faces and stuff, it totally works, I think.
Got these little brush strokes out in the environment as well. You can see if I select.
So the reason why everything gets highlighted when it selects one is because these are instanced, and instanced actors is basically when you send draw calls or when you send like information or data to the GPU, you basically tell it like, here's an object, it has these vertices and they're composited in a specific way, render that thing please. And then it says the next thing, and it's like part of the pipeline that it just like do this render, do this render, do this render, and that adds up a lot of draw calls. So one thing you can do instead is you can take everything that is the same shape, like if you have like 1,000 houses in a scene or whatever, you can just take one house and say this house is going to be in many different spots, and they just batch it all together in one draw call. So that's why it looks like this.
And what I want to do is kind of walk you through a little bit, just to show you a little like what some of our levels look in different parts of the game. But also I want to show you a little bit about lighting, because all of our lighting is dynamic. And we built several custom systems to support the look of the game and the way we wanted to light it. So it's the third level of the game, and you're playing the lighthouse. And
spoilers.
I'm going to pan way out for a second.
I want to touch on one thing he mentioned, that all the lighting is dynamic. I think there's many reasons why, even in games where the lighting doesn't change, where you still develop the game with dynamic lighting in mind. And I think a lot of people might be a bit frustrated that we sort of tend to move away from baked lighting a lot, that we used to do a lot back in the day, which is a lot more performant. You get like a ton. I'm not sure if you still get more detail out of lighting that you do now. You can do ray tracing and get like way better shadows and whatnot when you do baked lighting, but it does come with the cost of the process is slower, basically. So whenever you change anything in the scene, you need to rebake all the lighting. And obviously the more complex of a scene you have, the longer it takes to bake. Now, baking is not something that you sit and like watch the computer do. Obviously you can have like a server running and bake the scene for you and stuff like that, but it's still like a big hindrance, I would say, in the development process. Because like the nice thing with having dynamic lighting and like doing everything dynamically, is that what you see is what you get, right? Like if it looks good in editor, like the second you set everything up, it's gonna look good in the game. And I think that's something that's very important when you're developing a game. You want what you see in editor to reflect what you see in the game. You don't want there to be like a big mismatch, because otherwise you're gonna miss some details.
This is dynamic, as in the camera was following the player around, but the camera in this area did not allow the players to freely look all the way over here. So there isn't really anything over there, but the player could look up and around a lot this area. And for this level, the player kind of works their way all the way up through these levels, and you see they're all actually connected to each other, this whole pollen field area. And then eventually it comes up to here, and you can see as I'm moving through these different areas,
Oh, that's cool.
the lighting and wind and climate are all shifting in real time as I'm moving through here. And that's because a lot of this changes regionally based on where the camera is. We had to come up with our own system to help change those regionally. And this system was originally developed for Psychonauts 2. It's called the WEV system, or the World Environment Volume. You'll see that in our game, we have a lot of these things called WEVs. And you see here, they're all kind of named. We do have debug tools to let you know as a developer what WEV is active in any given area. And it lets us change a lot of things. We can...
Okay, this is actually really interesting. In Unreal Engine, you do get a lot of like tools out of the box to like shape your environment. So like lighting, fog, skybox and all that shit. And the way that it comes like by default in the engine is like it's sort of global. And if you want to change variables, you have to sort of like do it on this global setting. Doing it this way makes a lot of sense. I don't know why this isn't more standard, honestly, because this is very useful. I've done this a lot where like if you, for instance, want a day-night cycle, I'd prefer just having one actor in the scene to just like sort of manage that stuff, and then you sort of just update that and have everything tied to that, instead of having like a bunch of directional lights in the scene or whatever that you just move and change all the time. So he's got like distance weight functions here for like moving between different volumes, I assume. The fog, sky, volumetric cloud, skylight, and directional light. These are sort of like the base building blocks that you get in Unreal Engine that affect a lot of like how rendering is done when it comes to dynamic lighting in the engine. So like these are the things that you were tweaking for each volume, I guess, for these specific sections of the level.
So for example, if I grab the directional light rotation, you can see like I can just rotate the sun. So if I fly outside our WV volume, you can kind of see even the clouds change there. One of the funny things is you'll see as I fly around here, the exposure changes as well, because the exposure changes a bit based on what you're looking at. So if I look right at the sun, you'll see other parts of the frame dark, and if I look in a dark area, it brightens a bit. And that also changes quite a bit depending on where you're flying.
I want to touch on this because this is something that I feel like is always sort of misunderstood when it comes to lighting in Unreal Engine. All the like lighting values in Unreal Engine are based on real life values, and it's all based on how a camera works. So none of it is like how an eye works, which I think is a little bit of something of a misconception when developers do stuff in Unreal Engine. They sort of expect everything to behave like how you would see things in real life. But in reality, everything is based on like how a camera exposes film or a sensor or whatever. I personally always think that you get much better lighting when you have a specific set of exposure rating set instead of adding like correction after the fact. A lot of developers tend to do the thing where they don't get proper exposure, they just get an exposure, and then they tweak it in the post-processing values or in the tone mapper, which can give you kind of weird results sometimes when you don't know how the tone mapper works or like what it actually does at that end.
Here you can see the clouds are affected. You can see the colors in the environment are affected. The way the sun scatters through the fog is affected. The water that's out there is being affected. All those things are being affected. And so for our game in the outdoor areas, this would be kind of a baseline that we would sort of establish as where the direct sun is coming from. It has a volumetric scattering ability, so a lot of those sort of what is often called God rays scattering through there. If I increase this number, you'll see that they become even stronger, or if I turn this number off, go away. There's a lot of other things. These can control the sun disk it looks like. There's really a ton of control.
Yeah, so a lot of this control is stuff that we get from Unreal Engine. But I think what's interesting is at the fact that they've condense this control into separate volumes that they're managing themselves. I think that's really clever. Which makes a lot of sense. I probably want to recreate this if I did something similar to this, like at this scale.
Of the sun, it seamlessly blends them to new settings in different areas.
Like exactly, the biggest problem that you're really dealing with is the blending between areas. And like when you want to set specific fog or whatever, blending is always a bit of a hassle. So having control of the transition between volumes, I think is very smart.
So this is the Midlands right here. And if we go from the Midlands, behind this waterfall, spoilers everyone, there's a secret cave, all right? It's not really much.
I mean, if there weren't, we would revoke your game dev license. You put a waterfall, you didn't put a cave behind it? You get out of here, dude.
So if I go inside here and I turn around and then I slowly fly out, you can see what's happening here as I fly out. All those settings are changing, right? And so that's our system in action there. Now we don't do a lot of color grading in post. Most of the lighting you see in our game is actually coming from lights and materials and bounce lighting. We don't do a lot of like heavy color correction at the end. It's just sort of a stylistic choice I made for this game to not do that. That I really like is what's called a LUT, or a lookup table. These are little custom textures you can make that control the way the colors behave under different lighting circumstances. You can think of it that way. So for example, if I let's go into that cave. So I'm gonna grab.
By the way, the cool thing with LUTs in Unreal Engine is that you can make these in Photoshop. You can take a snapshot of your game and then bring it into Photoshop and do color grading there, and then you bring up the LUT into Unreal Engine. You can totally make your own specific
Grab
look.
the post-process volume from that cave. Unreal 5 is this really cool system called Lumen, and what Lumen does is it generates colors, bounce lighting. In a game engine where you don't have any bounce light, you wouldn't be seeing this happen here. You see, that's happening in real time. Like if I turn this off, if I keep increasing it, this is bounce lighting happen that Lumen is calculating on the fly, right? Unfortunately, when you're doing a non-realistic game, you want to do like a stylized game, you want to place a lot of lights around for different effects. And that requires you to place a bunch of additional lights. But as with all game engines, placing a bunch of lights, especially if they're shadow casting like all of our lights are, you can only place a few before they get too expensive. So what we needed was an ability to place additional lights. But we have hundreds, if not thousands, of additional lights placed in our levels to get a certain look. All right. Oh, I hit the delete button. All right, so what happens when you hit the delete button for the first time is you see Unreal looks at all the references in your level to make sure that if you're deleting something that affects other objects or is dependent on other objects, it tells you. Once this is done, you probably fast forward past this.
This is painful when you're working on really big scenes because there's a lot of dependencies everywhere for a lot of things. This includes when you're deleting stuff in folders on the engine as well. Like it makes sure that when you remove something in a folder that like there's no reference to that anywhere. Yeah.
So we wanted to place a bunch of additional lights in the scene, and we couldn't just use standard Unreal shadow casting lights, and we didn't want to use non-shadow casting lights. So we made our own custom Lumen lights that leverage Lumen, and they're basically free. And what they are is, in our case, if in our version of Unreal, if I go to Lumen, here you'll see that we have these Lumen virtual lights. Now these lights have their own special light type. So the common one I use is card. So you can see this is like having a softbox or a barn door sort of light. You can use them for really subtle color changes everywhere. And they do cast shadows. They can affect volumetric light. So if you look at in our levels, we have we have a lot of extra lights that are placed. So even in places where you wouldn't expect them, like if we go to...
I admit I don't know too much of like how Lumen works behind the scenes. I'm probably at some point I will do a deep dive and learn exactly how it works, because it's like a composition of different lighting techniques. It's like both screen space and proper ray tracing.
So how I originally came up with this idea was if you just put an emissive object in the world, so let's just say we just take Unreal's, we'll just take a basic, let's just take a cube, right? So just taking a cube, and if I...
Is he just like doing the same effect that an emissive material will have on the world and just hiding the actual material?
There you go. You can see that an emissive object, because of Lumen, actually affects lights around it. Emissive objects aren't lights. This is just part of Lumen. So I can just keep adding a million of these to the scene. I talked to Oliver and I said, here's what I kind of want to do. And so he basically did kind of some deep research on Lumen and said, what if I make a group of primitives that kind of basically work at the resolution that Lumen works at. But under the hood, it's effectively just injecting light into the Lumen system directly. And so we made our own custom primitives that do that. So, you know, that's kind of the foundation for a lot of the lighting look.
Cool.
And there are some limitations of this approach, one of which is that it's very soft. But because I was going after a painterly stage feel, I didn't want a lot of hard, crisp shadows everywhere. So it actually helped us to have that sort of lower res feel to it.
God, it's like the stuff that the environment that he's showing is so good looking. Like, it's crazy, and like everything looks good. The environment, the lighting, the particles that they use in the scene, the fog. They're really good at this shit. Look at this crepuscular rays as well you got there.
You can see that, you know, if I, well, let's just leave this fog density. Let's just increase it really high.
I love that they've said, like, don't go higher than 0.05. And he's like, one more! More fog!
Now, of course, our game involves light because you're a lighthouse. And so, you know, the player has these sort of shadow casting light attached to the lighthouse. So you have this beam here and you have your focus beam. And the other thing you'll notice as the lighthouse moves through this level, you'll see, and if I get to a dark space, you'll especially notice it. You'll see that it looks like it's being hit on the sides from lighting. You see that there's like kind of a cool light from the left and a slightly warmer light from the right. So those are lights, but they're attached to the lighthouse. They're actually not in the level at all. So we have volumes that, and I'll sort of see if I can demonstrate it here. We have volumes that control the color of the lighthouse's beam, the color of its windows, which you see get brighter when you use your focus beam, and those sort of rim lights that are attached to the lighthouse. And that uses another volume called a...
And I'm assuming they always move towards like where you're looking, so you always get a rim light from the perspective of behind the lighthouse. Otherwise, it wouldn't be a rim light.
Property
right?
blending volume, or a PBV volume, that lets us specify how bright the light is, what color the light is, both the light that the player is aiming, as well as the lights that are on the lighthouse.
So a detail like that, with like they want to have full control over how lighting that hits the lighthouse is affected by the environment in a specific way. That tells you so much about Double Fine, I think, because Double Fine are so good at like creating concept art for something and being like, this is what we want it to look like, and then they put it in engine and like, it doesn't really look the way that we want it to look like. Yeah, because Unreal Engine works in that way and it's realistic lighting, blah, blah, blah. And they're like, nah, man, it gotta look, we want it to look like this though. So you add these like little details here and there, technically, to make sure that what you see on screen is what they actually want you to see. It is true, like if you want very specific rim light, you have to control that yourself. And if you can't control it with the environment, you have to do little tricks like this to be able to achieve it. And I think that's sort of like what sets a really good game developer apart, is like when they're able to accomplish what they're setting out to create.
So if I want like the default beams to be stronger, I can do this. If I want those beams to be a different color, I can do that as well. And so these will blend across the entire game as you're moving around. They subtly change. Now those rim lights that are on the character here are also here. So if I boost this up, you can see that, or I can change its color as well. So all these things change over the course of the game as you move through the game, and most of the time the player is not even aware of it at all.
I'm also assuming that they're using light channels for these lights that are on the lighthouse, because you don't want this light to affect the environment.
Make sure. Now you can see here, we're going to go into this future area here by shining this light, and it's kind of a positive area here over where nature's kind of overtaking.
Preparing textures, preparing shaders,
the land again. And you can see that like the lights here reflect that green, and they're warm. They're not at all like that weird pink I tuned. Setting up the lights on the lighthouse to always be in rim lighting was a little tricky, because basically we have a couple lights attached directly to the lighthouse, and they're always rotating based on where the camera is.
Yeah.
So you always get a nice, pleasant lighting, and that's not only there to help tie it into the environment, it's there so to make sure the player can see the character at all times, because we have a lot of dark areas in the game, but also, again, there for whatever emotional notes we want to hit at that moment. And now we're going to be joined by Zach Baharov, lead animator of Keeper, who's going to show us some behind the scenes.
I wanted to talk about a little bit, show you the behind the scenes of how we put together the player characters and also the birds. The first time really you take control of the lighthouse, once it has its legs formed, You're in this sort of stumble state.
Drunk walk?
We call it drunk walk.
Drunk
yeah.
walk?
Try-
I need to play this game.
We wanted to give the player the feeling of, this character who's kind of finding their legs for the first time, I guess. There are quite a few animations that make up this section, and this is what we call blend space. It's a 2D graph of sorts, and each of these little dots represents an animation sequence.
Yeah, it's like different dimensions, right? So like when you're going left in the blend space, you want the leftmost point, you want one animation, and the rightmost point, you want another animation. So like if your character's walking left, you want this, and if your character's walking right, you want this, and then you can blend between those two on that dimension, and then obviously you have up and down as well, so like walking forward and walking backwards, and then you can just blend between these animations. So it's like 4 different animations running at the same time, but you're blending between them in this space, basically. And this is like a preview window of what it will look like. So you can put your cursor in the blend space and see like, what will the animation look like if I'm trying to walk this degree?
And as we move through these, you can see that they're actually these are poses in this case.
Yeah, and poses, so also really cool, you can use multiple blend spaces, of course. So you can have for poses. One common thing is when you're making like a third-person shooter, is you have blend spaces where like the character's aiming straight, aiming up, aiming down, aiming right and left, right? So then when you're animating, you just need to like, where am I pointing right now? I'm pointing there. Where's that in the blend space? So I can get the correct animation for it. So, and then you have that, and you can add on top of that multiple blend spaces for like the actual moving part. So sometimes you just have poses that are just like straight up no animation. It's just a pose that the character is standing in.
And this is sort of which way the lighthouse is leaning. And if you go too far, we go to the appropriate falling animation.
There's a montage.
Here. So, and we stay kind of in this last pose here until the player does the appropriate.
And these like little, you can see there's like little events here. So these are notifiers. So like if you want a sound effect to play at a certain point in the animation, you can put a little notifier there and that will trigger a piece of code to do something. Or in this case, force feedback, I guess. Or you want it to rumble. The controller needs to rumble when it hits a certain point of the animation.
And then once you, I think, touch any control, we played this sort of impossible animation of this lighthouse hauling itself back.
Ooh, one thing I'm also noticing here is that they've disabled IK, so inverse kinematics, for the legs, and then they gradually bring them back as the animation is ending. And if you don't know what inverse kinematics is, it's basically when you solve, like if you have an arm, for instance, and you have like bones connected to like how it moves and decide how it moves, right? So if I want to rotate if I want to like reach out my hand, right, I would have to like, okay, the rotation of this needs to be here, the rotation of this needs to be here, and the rotation of my hand needs to be over here, right? So that's how I get like that motion, right? But with inverse kinematics, what you do is instead you solve based on where the end bone is. So if I say that this bone is here in space, it solves like, okay, where does this bone need to be and where does this bone need to be? So that it basically solves like based on that. And that's a very common thing you do with legs and arms and stuff like that in games. For instance, a very common use case is when a character steps on steps, you want the foot to actually like land exactly where the step is. If you have an animation, just like walk straight and then the foot suddenly needs to be at a certain height, you can then do an inverse kinematic where you say like, hey, the foot is supposed to be at this height. Solve the rest of the leg.
So this is another blend space, but this is the actual walk. So these are different. There's walk forward, walk right, and backwards. So you can do the full, you can see now I'm kind of walking. So I'm walking forward and then I'm walking a little bit forward and to the right and then really fully just to the right, kind of strafing. At one point you could do really tight circles with the control stick. And we have this sort of procedural layer of steps, little mini steps being taken by the lighthouse, and it was kind of like leaving its legs behind, but trying to catch up. Not really playing an animation, but just placing its legs kind of all over the place, and sometimes it was just too frequent, and sometimes the legs would kind of get left behind, and it would be very slidey. Like
I like the nervous twitch I had for a while. We had like one leg where it was like just doing
it was
this.
yeah. We ended up implementing just a whole bunch of turn animations. We definitely have a 180-degree turn, a 90-degree turn, but I think we have 45-degree turns, maybe 30s, maybe even 15s. I know I authored all of those.
Plus, you've got all the real-time IK going on with 4 legs, so it's placing them at the appropriate heights and stuff, and that's also challenging. There's not a lot of games that do that.
It's interesting to hear that they didn't do procedural animations for legs, because this is definitely one of those cases where like you see so many examples of procedural animation where they do this kind of like spider leg moving kind of thing. But I guess they just didn't like the way it moved when they did that, and they wanted this like more control of like how the animation moved with the lighthouse.
The lighthouse is made weightless by this pollen fluff that it is accumulated on its body, and so it can float. Okay, so as the lighthouse was floating around, we quickly found out.
So this is like one of my favorite tools in Unreal Engine. I love this tool so much. This is a control rig.
Control rig is the system that is part of Unreal that allows you to create, among other things, an additional rig on top of the character. You see these controls in here. So I have this little dot selected here. It almost acts as the analog stick. So as I move it around, you can see this.
Cool.
Imagine this is the lighthouse in midair, and I'm moving the stick around. It's sort of reacting in a reverse. The chain goes up. The joint chain goes up the column there, but actually it's moving head first.
Oh, I love shit like this. Yeah, control rig is, like you said, it's an additional rig on top of the original rig, and you have so much control in Unreal Engine with the control rig. You can completely animate. You can create your own custom animations in control rig with the sequencer and everything like that. You can completely discard the old traditional way of creating like an animation in a different software and bringing it into Unreal Engine. You can create everything in here. The tools are better now than they used to be, but they're still a little bit clunky. They have layering now and stuff like that in 5.7, but it's such a cool tool, and you can program everything. It's so powerful and it's so good. I love control rigs so much.
I mean, would you say it seems like control rig, when we started using it, really just improved the game feel across the board, because it let us tie very specific modifications to the way things felt based on player input. In a way.
I think actually our first implementation of control rig was to get Twig feeling better on some of these objects that she interacts with. And control rig allowed us to basically map player input or the stick input to something like the chest of the bird. And then everything else on the bird's body could react to that.
Oh,
and
cool.
So the first implementation, everything was moving together, and it just felt like you were
like stuck to it like a ornament. Yeah.
You're rotating this wind. You're winding this winder or crank, and the bird just happened to be there, flapping its wings attached to it. It did not feel at all like the bird was initiating that motion. And with control rig, and you can see here as I'm moving the stick around, you can see all these controls moving back and forth. So it really felt like the bird was and the player was making this change, and it was affecting the world.
Hey, I'm Will. I am a senior environment artist here at Double Fine, and I worked on Keeper. So I'm here to talk about maybe some of the more technical aspects of the art pipeline. So I'm in one of my favorite scenes here. This is the Hall of Elders. So one of the first things I like to talk about that is unique about Keeper is that just about everything has no textures, at least not in the traditional sense that most games have, like 0 to 1 map. So I can show you a little example of that here.
Well, if there are no textures, how do you do it then?
Instead of all those traditional maps, we generated a ton of masks. So we masked like edges, cavities, all sorts of great stuff to help us like control the look of the assets. And then over here we have just tons and tons of controls for like every layer.
What the shit?
And then we have a whole library. As I move it, you can see those textures are swimming around. They're changing because the context is changing. New surfaces are now pointed up, so moss is gonna take over there. The whole surface itself is moving, so the texture also has to move so that it is consistent between, say, this rock and this rock.
What a weird workflow, but I can totally see how it works.
Just about every inch of the game is covered in these paint strokes. They're kind of hard to miss. And then you grab this foliage tool, but you'd get in there and make all these little, and maybe simplifying.
Oh, cool. So they have like brush strokes as foliage, and then he's just adding it.
Not a lot of games will go for this sort of thing because it is a lot of work. It also is
it's fucking crazy.
There's a lot to it that you just sort of build up over time.
Yeah, not gonna lie, I have no idea if I were to work in this system. Like, I don't know where to begin. Like, how to create something with this. This seems super cool and they're very different. It reminds me a lot like when concept artists will take like screenshots of something and then do retouches on it. So they will like draw on top of it. Like a lot of the concept art for Satisfactory, it's like we take the in-game model, pose it in a certain way, and then a concept artist will sit there and draw on it and make sure that like the rim lighting is perfect the way it should be and that like the colors pop in a certain way. So it feels very similar to that, but you're doing it directly in the environment with like foliage actors, which is crazy to me.
Sort of the reason I would always recommend only working from the camera angles is because it's really easy to go around and just put strokes down, but then...
It's a very good point here, like since the camera's static or moving, you have to like create everything from the perspective of the camera because the strokes will be facing the camera.
If you go and play and see it from the camera, like seeing these strokes off angle, seeing them on their side gives a really bad feel, you know?
It's very reminiscent of like when you create like Into the Spider-Verse, for instance, where that movie is 3D, but they've added like retouch elements of 2D on top of it to make it feel more 2D. You have to do a lot of like tricky shit to get that like 2D look when you do stuff in 3D. And you have to do like a lot of weird special things. And this seems like they made the entire game like conceptually with that perspective, which is crazy to me.
Hey, I'm Asif Siddiqui. I was one of the level designers on Keeper, and today I was just going to show you an area where the gameplay and camera systems really came together to complement each other. But this is where we start pulling a couple of different levers to help the player out. You can see here that as I'm approaching this gate, the camera's only going to follow you so far, and that sort of implies that there's no progressing beyond this point. You've got to do something here, aside from the door ahead of you. But then, if you send Twig over to one of these side winders, you can see that we've moved the lighthouse over into a specific spot, and we're keeping it in frame so that you can aim your light around. And now you can see that without your light trained on this thing, Twig is not going to want to stay on the winder. Another thing that was really interesting that isn't often apparent to the player, but it makes a difference just subconsciously, is that there are all these events that happen in the game, and under the hood, we are telling different cameras to turn on and off based off of your progress. The camera's no longer hanging behind you. It's now smoothly following along and continuing to move with you into this space. This is a very dumb little thing that I really wanted to get in just for fun, but there is a point past which we want to block the player in and prevent them from going backwards, just because it's a way of saying you don't need to go back there anymore. So we've closed that gate behind you, and if you happen to come back again, you get this little keyhole shot.
Oh shit!
That's maybe 0.5% of people will probably see, but it's just a fun perspective on the character, and you can see some of these little...
That's such a fucking clever thing. Holy shit. I really like the way camera management is done in Unreal Engine, because you can have like so many cameras in a scene, and then you have like a camera manager, and in the camera manager you decide like which camera is active, and how you blend between cameras is also managed through the camera manager, which is really nice, because then you can have these things where like if you have one camera position here, another one here, you want to like have a nice blend between the two, and it should feel like it's one camera. That's very, very easy to do in Unreal Engine. You can also do like cuts like this, right, where it just cuts to another camera angle. But yeah, making these like seamless transitions between cameras is very, very easy to do in Unreal Engine. And given the fact in this game where there are probably multiple cameras and on different splines and whatnot, that it's just blending between, where it feels like you're just going through one smooth camera movement, I think it's very, very clever.
But if I were to go back and enter a different era, I'll interact with this switch here. So we're going to see the world change around us a little bit. You know, and it's hard to know like exactly what the impact is of this change is everywhere in the level. Like we show you the most important stuff in the cutscene, so you definitely don't miss that. You know, we want to see that building come back together and twig changing into a form that, you know, renders it unusable. And if I were to switch eras, you can see now that suddenly the camera's...
This effect is really cool. I'm assuming, so what it does here is like you have, I talked about before layers of in the partitioning system. I'm assuming what it does is like it unloads and loads another layer and does like a screen wipe effect. So like you don't see the actual change in the environment. And the cool thing with the way they've set it up, as far as I understand it, is like, you remember those volumes you talked about, how like lighting, how that affects the lighting with these volumes? Those volumes are probably placed in each of these layers or loaded in along with those subsequent layers. So like you'll get the change of lighting as well as automatically from that system, just because it's part of the level.
So if you look at this space, seems simple enough, but if I unhide everything, you can see that there's this just insane tangle of cameras.
Jesus.
And
oh my God.
Yeah, this is sort of like...
Holy shit. I swear there's a game behind all that. I love that there's like, I think this is like a collider where like if you walk through this collider, will save the game. I like that they clearly mark that. Look at all these cameras everywhere. Like a puzzle icon over here. A lot of lines, a lot of collision. It's possible they also like don't hide anything just to make it look more messy.
And all of these cameras have some degree of what we called fin width to them. And the fin was basically a way for the camera to move off the rail a certain amount of distance, right? So if I was to like select one of these.
It's interesting that they actually use dolly rails to visualize where the camera is in space instead of just a regular spline. I think that's really interesting because like when you're old school movie making thing, like when you have a camera movement, you put them on these dolly rails. So like you had a wagon and you put the camera on the wagon. That's basically what this is like emulating sort of, or pretending to be. I think that's really cute.
You can see these lines here on the side that are showing
sort
of where the camera sort of stays really close.
So like how much you're allowed to move away side by side on the dolly rail.
A lot of my work on this game was moving this thing around.
It's even got the little dolly cart underneath the camera. Yeah, this seems like a lot of work, at least in this environment. Like I guess it makes more sense where you have like a more linear path, but like here it's like, holy shit, dude.
I'm really proud of how this area turned out, and yeah, I don't know, hopefully you never struggled with the camera too much, but anyway, that's just an example of...
Not as much as you struggled with the camera, clearly. Dope. I need to play Keeper now. Jesus Christ. So yeah, this is actually really interesting. I learned more than I thought I would, actually. And I actually feel like there were a few things that I think I'm going to adopt. I really like the way they handle volumes to manage the lighting and Skyosphere and all that shit. I think I'm going to see if I can adopt that system into the game that I'm working on. Not that I will need it to the same extent that they do here, because I'm not making... Yeah, we'll see. So yeah, I hope you enjoyed that. I hope I gave some fun perspective from my end into like the way they did it. And yeah, buy Keeper. All right, that's gonna be it for this video. Hope you enjoyed it. I'll see you in the next one, possibly. Bye-bye.